So good day everyone. My name is Xavier O. Bacolado and I'm going to report about chapter 1.5, what constitutes conclusive proof. So conclusive proof is talking about convincing one that you are thinking or what you are doing is correct by giving conclusive evidences or outputs in which that can justify which is correct. So it is also applied to generate findings that are practically useful in reaching conclusions or decisions making. So research is designed to create new knowledge. So this new knowledge needs to be substantiated appropriately. So novice researchers must convince themselves that the results and conclusions are valid and supported by strong evidence. So this is commonly done using more than one of the following techniques. So research was created mainly to discover new knowledge. So for this knowledge to be reliable and for it to be successful, this needs to be tested and to provide evidence that, especially by the research team, and to be thoroughly checked and examined by the experts in this field. So research objectives and data requirements needs to be clearly defined. So for a researcher to start research, they tend to look for a problem that doesn't have an answer. That is why they are gathering informations and data to come up with a conclusion and to answer the problem, and it should be supported by strong evidences. So here are the techniques that I have mentioned. So first is that experimental measurement, or what we are known particularly using standard test. So for experimental research, it is a critical component of model development as they are needed to validate the accuracy of the model predictions. Next one is theoretical developments. So from the word theories, so these are formulated to explain, predict, and understand phenomena, and in some cases to challenge and extend existing knowledge within the limits of critical bounding assumptions. And then second is logic and mathematics, and then numerical simulations. So numerical simulations, it is to compute approximate solutions to mathematical problems by discretizing continuum process. So it is also used when analytical or symbolic approaches to solving math problems and also computationally difficult. So statistical analysis, so it is to investigate trends, patterns, and relationship using quantitative data. So it is an important research tool used by scientists, governments, businesses, and other organizations, and also comparison with previously published research outcomes. So in this one, researchers tends to look for data or information from the other researchers' outputs or their outcomes. And the last one is the use of multi-parameter optimization methods to obtain the best outcome of the design. So ideally, a research team would engage in many, if not all of these techniques to verify its result. So the techniques that I have shown earlier are what researchers mostly used in gathering data and information so that they can verify every result and if it is necessary and essential to their study. So this gives the independent reviewers of the work the best possible proof that the new knowledge has been validated and the conclusions are correct. So it is also a way for the reviewers of the study to check if the research is successful in terms that the new knowledge was validated and the conclusions were correct. So often, however, there may be problems in using this approach. So for instance, so there are no standard experimental methods applicable to a particular research investigations. So repeated experimental measurements are not possible, so that statistical support is difficult. The theoretical framework available are too simplistic to describe the outcomes. So there is no prior work which closely resembles this investigation. And lastly, multi-parameter optimization is not possible as computational models are ineffective. So in doing a research, you can encounter challenges and difficulties in gathering informations and data. That is why researchers needs to be flexible to use other methods or techniques so that we can gather informations proficiently and also we can gather strong evidences. So next one is these difficulties can all result in a probability of failure or project risk assessment. So this is usually expressed as a probability. So the publication of research results mandates that some supporting evidences is provided. So a failure to do this will result in a failure to have the research outcomes accepted. So it is very important that the research team designs a project in a manner which ensures that sufficient supporting evidence is available at its completion, either from the work itself or from the other published work. So it is very important that you can have supporting or strong evidences that can support your informations or your research so that your work is okay or your work can um, be considered good or it can help the society because you have strong evidences of that. So in mathematics, the concept of upper and lower limits can be applied to gain information about the solution to seemingly intractable problems. So for example, if a function is not integrable, one can choose two integrable functions. So integrable means that one cannot be integrated using analytic means. So one of which is always greater than the function and the other is always less than the function. So by completing the two simpler integrals, one can deduce the range within which the unknown function lies. So in the same manner, simple models which provide upper and lower bounds to a more complex problem can be solved theoretically and or computationally to deduce the likely range of outcomes from the more complex models. So this method can provide additional support to research results even when a complete model has not been solved. Alright, so I have here some examples. So my examples here are questions for probability. So a glass window with high-rise building falls to the street below. So a structural engineer is asked to calculate the probability that this event will occur again. So how can the engineer verify the results given that only one event was recorded? The other one is the flight control system in an aircraft is rated as 99% reliable. So would you fly in this aircraft? And last one, a civil engineer quotes a dam wall as being able to withstand a 1 in 100-year weather event. So would you be happy to live beneath that dam wall? So in all cases, conclusive proof is required for the safety of the population, and we researchers and also engineers, we are bound to look for the solutions or the answers so that we can keep the safety of the people and also to those who will be using or benefiting from our research. So that is the importance of conclusive proof in doing a research. And thank you for listening, and that is all.